Hello, my people. Hello, viewers. This is your pioneer maths, physics, and further maths class. I've been on research for some time, but I'm back on board now. Now, here, what I bring for you is for all. When I say all, I mean all. But for now, I'll be taking some topics based on your curriculum in secondary school. For maths, physics, and further maths, SS1, SS2, and SS3. For today, I'll be taking projectile, which happens to be the second topic of SS2 physics class. This is based on the request of some students. So I'll be taking that today, but I'll be taking other topics. I know the first topic for physics in SS2 should be scalar and vector quantities, but projectile is the topic to be taken today. Now let's start. Let's go to the issue of the day. Projectile. Projectile is the topic. What is a projectile? This can be defined as this can be defined as the movement of a body in a parabolic manner. Parabolic manner. So what this means is that if you see anybody that is moving in a curved manner, it is most likely that it is what? A projectile. Such kind of motion is called projectile. Now, another name for projectile is what? Trajectory. Trajectory is another name for it. Now look at the picture below. Let me draw a picture to represent this motion itself. This motion. When a body is projected, it moves like this. Parabolic manner. So where here we have our velocity u, and here is taken to be the vertical component. Vertical component here is horizontal component. Now we always have something here. We always have angle. We always have angle here. There is angle to this line, which is theta. Between here and here, we call it maximum height. Now, here to here is the maximum horizontal distance. Maximum horizontal distance. Along here is our uy, which is the representation of the vertical initial velocity. Ux is down here to represent the initial, the horizontal component of the initial velocity. Now, what are the terms that we need to work with here? We need to work with some terms here, and that is what we call the parameters of what? Of projectile. That's the next thing we need to discuss here. parameters of projectile is the next thing here. So that's the next thing we need to discuss here. Parameters of projectile. Parameters of projectile. What are the parameters of projectile? The first of these is the angle of projection. Angle of projection. That's theta. So this can be defined as the angle between the line of projection and the horizontal So it is measured in what? It is measured in degree. That is on that. The number 2 of the case here, number 2 here is maximum height. Maximum height is denoted with h. This can be defined as what? The maximum vertical distance covered by a projectile. It is measured in meters. It is measured in meters. That is M. Number 3 here. Number 3 of the parameters is what we call range. Range, that is capital letter R, can be defined as the maximum horizontal distance covered. Maximum horizontal distance covered by a projectile. This can be what? It is measured in what? Measured in meters. Measured in meters. M. Number 4. Number 4. Number 4 is time of flight. That's capital T. This one is the total time taken. The total time taken. Total time taken from point of projection to the line to a point on the line of projection, the line of projection full stop. Now, this is measured in what? It is measured. It is measured in seconds. Now, these are the basic parameters. Then the last one here is initial velocity. This one is very, very important. U. We all know what velocity is. I don't need to be defining that. But it is measured in what? It is measured in meter per second. But if you want definition of this, let me just give you something. This is the starting velocity. Starting velocity of a projectile. That's all about that. Now, having defined all this, we still have some other things to consider. And that is, those are the things that determine all the equations. Now, from here, let's look at some other useful parameters that are not mentioned. Other useful parameters that are not mentioned. Because those ones are the basic one. Other useful parameters not mentioned. The first of which is going to be 1. I call it half time of flight. What's the meaning of this? Let me draw again. Let me draw again. If you have it like this, see that? You will see that this is the starting point. Here is the starting point. As the body moves up like this to this place, you will see that we have upward movement from here to here is upward movement. Upward. On getting here, there will be a stoppage, momentary stoppage, and it will move downward. That one is what? Downward movement. So the time it takes to move from here to the top here is t, small letter t. While the time it takes here again from the top here again to the same level of the point of projection is also t. So that is why it is called half time of flight. So it is always t, small letter t. So it means that the time it takes the body to move from the point of projection to the maximum height is small letter t. The time it takes the body to move from the maximum height to what? To the line, to the point on the line of projection is also what? Is also t. Which means that it takes the same time to move upward and the same time to move downward. So as a result, we have one equation here, time of flight, which is the total time taken, which is what? The total time taken. Time of flight, which total time taken is always 2t. Because the time it takes to move upward, it's not time to move downward. Now, number two. Number two is what we call anytime. Anytime. That one is ty. Now, if a body moves from the point of projection to the maximum height, that one is definite. But if it is along the line, it didn't get to the maximum height, we call that one ordinary t, ordinary time t. That is ty here. So that is moving upward. Then another one here is any height. Any height. That is small letter h now. Small letter h. That is, it didn't get to the maximum height, it's just maybe around here. So that the height, you can see that it's not total maximum height now. Like, let's say from here to here, from the ground level here to this place. Not the total height now, it is just ordinary height. Then we also have another one, which is any horizontal distance. So let me just take half horizontal distance. Half horizontal distance. That's x. So it means instead of you to move from here to here, it won't get there. And we also use this for any horizontal distance. So is that any or half horizontal distance is what we use for this x. So, and if it is half to say like that, it means x will just give you half of our other point. Now, another one we need to consider here is the vertical component of initial velocity. That is uy. The next one is the sixth one. That one is number 6. Horizontal component of initial velocity. That is ux. Then the seventh one is going to be any vertical velocity, whether it is moving up or down. we call it Vy. Now, these are the things that makes up what projectile is called projectile. Now here, we want to discuss more on this, delve into the equation of projectile. How they come about the equation of projectile. Those are the things we are going to discuss. First is to look at how this thing is being formed. We have the velocity like this, u, y here is uy, and horizontal like this, we have ux, and the angle is here as theta. If you look at that, we have this here. If we combine it together, you'll be seeing that we'll be having the vertical, the horizontal, and the velocity u. Here is theta, here is angle 90, here is uy, and here is what? Ux. Don't forget that this thing will move like this to this place. Now, let's look at their relationship. From here, you can see that here is hypotenuse, here is opposite, here is adjacent. Using trig ratio, what happens there? You will see that we'll be having sine theta is equal to opposite, which is uy, over hypotenuse. That is to say, uy is equal to u sine theta. Then again, we have cos theta is equal to ux over u. That is, ux is equal to u cos theta. So that one being said, let's now consider how we can calculate time of flight. Time of flight. Everything here will be calculated at when at maximum height. At maximum height, what do we have there? We have the u equals 0. Why? When the body moves upward and get to a point, it will stop momentarily. That point where it stops momentarily, the final velocity is v is equal to 0 there. That is, it's not moving. The body will first stop before it turns downward. If it doesn't stop, it won't come downward. It must get to a point where it's momentarily 0 before it turns backward and coming downward. So final velocity is 0. Our A here, acceleration is acceleration due to gravity. Then we have our time here is equal to t. Why our vertical distance here? Our vertical distance, just like I said initially, is equal to h in this case. Now, if you now use the formula that, equation of motion says that, but we have what? We have v equals u plus at. We all know that equation. We all know that equation, I believe so. that we all know the equation. But V equals U plus AT. Therefore, here we have 0 equals. Now, in this case, our U will be what? Because it's vertical, UY. U is equal to U sine theta. Don't forget. This is going to be UY plus, oh, sorry, here is moving against gravity. Acceleration is going to be negative. When it's moving against gravity, we have our minus G there, then times T. In essence, what happens there? 0 equals what? Uy minus gt. Take it to the other side. Gt is equal to uy. So t equals uy all over g. That is to say, t equals u sine theta all over g. This is equation 1. Now, from there, we can recalling. I said at the other time that our t is what? The time of flight is what? Don't forget that time of flight is 2t. That's why the time of flight, capital letter T, is written as 2u sine theta all over g. This is the second equation you need to know. The second equation you need to know is this. Just be noting it down. Now, let's go again. Also, we know that we need to calculate the maximum height at this point. Maximum height to be calculated. Maximum height to be calculated. Now let's go for maximum height. Maximum height. What happens there? That's capital letter H in this case. All we know is that S equals ut plus half at squared. In this case, if it is moving upward, our formula will be h equals, that's the s, in this case the distance, uyt minus half gt squared as it is moving upward. So I will explain this later. H equals u sine theta times t minus half gt squared. This is when it is what? Moving upward. Moving upward. That's the formula we use there. So we have this as the third equation. The third equation. Now, when it's moving downward, as it is moving downward, as it is moving downward, moving downward, that is downward motion. Now, what happens there? You will see that we'll change it immediately. At that point, Our initial velocity is 0. Is that okay? Our initial velocity. The h will just become half gt squared in this case. But I'll still give us another equation that will make us happy. Now, also, v squared is equal to u squared plus 2as. In this case, if we use what we said all the time, the final velocity is 0, that's squared. Here is uy all squared plus 2 times minus g times h in this case. We are now having 0 is equal to u sine theta all squared minus 2gh in this case. If you transfer 2g to this side, it becomes positive as what? As 2gh is equal to u squared sine squared theta. Now, that's not the end. That's not the end of the whole story. From there, we'll just say that guy h will just come down sharp sharp. That is, h now will become u squared sine squared theta all over 2g. That's equation 5 to say. That's equation 5 to say. Now, that's on that. Let's now discuss as it is moving downward. Moving downward, initial velocity becomes 0. See that? When it's moving downward, it now moves from here, up here, downward. It moves downward here. The final velocity initially when it stops momentarily is 0. So it's now starting with another velocity which is also what? Starting with a velocity here, which is 0. It's starting with a velocity u equals 0 in this case. Now, we are going to pause at that point. Let's now talk about anytime. Anytime. Oh, before that, let me discuss the horizontal level. The horizontal level. Horizontal level. If I discuss any time now, okay, let me discuss any time. At any time ty. So when it is moving upward motion, for sure a equals minus g. Our time is taken to be ty. Our velocity, initial vertical velocity becomes what? uy, which is u sine theta, as we all know. Now, final velocity will change. Final velocity is now going to be vy because it's not at the maximum level. So let's take them one by one. For the first equation of motion, v equals u plus at. So we'll be taking vy equals u sine theta minus gty in this case. So here we create an equation here, and that's what we have. Equation 6. let me take downward motion here. Downward motion here. Downward motion. Downward motion here. At that point, we have our A to be G. Our time equals Ty still. Uy equals U sin theta still. U sin theta. Uy equals U sin theta. U sin theta. Then we have our final velocity to still be what? Final velocity is still what? Final velocity will be written now. Why is it giving me stress? Final velocity is equal to Vy still. In this case now, as it's coming down, we have Vy equals U sin theta plus now, because our A will be positive in this case, Gty. Now, another equation has been, okay, that one, I need to note it as equation 8. That's equation 8. Don't be perturbed that the equation is getting too much. Yes, it is. Because most of the time, oh, it is equation 7, not equation 8. Equation 7. Most of the time, people often forget these equations that they exist. When you now see question that goes in that line, asking you velocity, the final velocity at time, so, you now be saying, what is really happening? So what's happening is that you don't know that it exists. So now from here, we take the second equation of motion. S equals ut plus half at squared. Don't forget this side. This left side is for upward motion. So here, we now use our height. Ordinary height is what we use here. Ordinary height, that is h, is what we use in this case. We use the capital letter H, maximum height. So this is at any time. It's going to give you U sin theta times T y minus half GTY squared. But here, what do? We just say that our H is what? Our H, what's happening? Our H is equal to U sin theta T plus half G T y squared. Ty squared. So now here we have it like this. This is 8, and this one exists to give us what? 9. Now, but at times, this H will just give you half GT square. It depends on what is happening, what we are given at the beginning, but we still leave it like this. Now again we have v squared equals u squared minus 2 or plus 2as. In this case, we'll be having vy squared equals u squared sine square theta minus 2gh in this case. So this one gives you what? Gives you, this gives you what? It gives you equation 10. And at this side here, the downward movement will be having vy equals u squared sine square theta plus what? Plus 2gh. Now I'll still differentiate at a time, don't worry. Now here we have what? Here we have our equation 11. Now when initial velocity from top is zero, the equation 9 becomes what? Becomes h equals half gty squared, and that's equation 12. Then equation 11 becomes what? Becomes vy, oh, squared is there, y squared is equal to 2gh, yeah. That's what? That is equation 13. Now, that's not the end. That is not the end of the whole story. We still have some other things that we need to discuss here. When theta is not given, when, oh, no, horizontal level, horizontal level. Now, we consider many categories at this point. So when we have maximum horizontal distance, which is r. Here we take our r, our a here is 0, no acceleration due to gravity here. Our time is time of flight, that's t. Then our ux is equal to u cos theta. Don't forget it is on horizontal level. In this case, we know but s equals ut plus half at squared. In this case, it will be r equals ux times what? Times calculator t. which means that we have R equals U cos theta times 2U sin theta all over G. From there, we have what? We have our R being what? Our R is therefore known as U times U. Let's take U times U. We have U squared. Then I want to rearrange that one. We'll be having 2 sin theta cos theta all over G. Now, from mathematics, from further maths, sin 2 theta is equal to 2 sin theta cos theta. Therefore, our equation becomes what? U squared sin 2 theta instead of this 2U sin theta. 2 sin theta cos theta, we'll be having it as sin 2 theta all over G. This is the 14th equation, right? Now, if you now have half flight means that it's not giving you full flight. It's either moving from the point of projection to the maximum height, or from maximum height to the line of projection, or what? Or ground. If it's moving from ground to the maximum height, or maximum height to the ground level, like this. It goes like this. We're talking about halfway, like this. Halfway. It's either it's moving from point A to B, or it's moving from point B to C. So this is what we call half flight. Is that okay? Now from there, we'll see that our S now, X is what we use, is equal to U cos theta times small letter t. It will be small letter t now because it is half flight. You understand? So from here, we have it as half of what we have up there. So we can leave it as, at times people write that ux times t, or we write as half of r. Anyhow we write it, we're still in line. Now, but there are some things that we need to consider here because of some reasons which people don't really consider it. Now let me make this one equation 15. Equation 15. I'm such a person that I don't like solving questions until I discuss all the rudiments, that is making the work function as expected. I make it 15. Now, it's possible when theta is not given, when theta is unknown, some things will happen and you'll be saying, what are they saying? What are they doing? Is unknown, sorry. At this point, what we'll do is easy, right? So what we'll do is we'll just go to, h is taken to be, at that point you use h equals half, go to that formula up there, Let's go this place. This is what we are going to use at that time. Is that okay? Now we use this at that time. So we use that equation, half gt squared. From here, if you look at it religiously, you will see that this will give you cross multiply 2h equals gt squared. That is t squared equals 2h over g. That is c small letter t is equal to square root of 2h over g. So at that point, we take our x, that is half-life, to be ux t, and x equals ux root what? 2h over g. I believe that one is clear. Clear enough. So in this case, watch out very well. This one is one equation on its own, and that's, I call it equation 16. While this one is another equation. They usually ask this question in number 8. That is the theoretical part. The first question they will ask under number 1 or 2 and 2 most of the time. This is the formula we use for physics question. So in the theory part, so watch out for that. You always see it there most of the time. You don't miss it. Now again, we can still go further to say that, what we have there, t is also working there. T cap letter t. We can see that again, 2h is equal to g t squared, but all we know is that capital letter T equals 2t. That is small letter t equals t over 2. So we can now come back here to say that 2h is equal to g capital letter T over 2 all squared. That is 2h equals g t squared all over 4. Cross multiply g capital letter T squared is equal to 4 times h, 2h, and that's 8h. That is t squared period, the time of flight, is equal to 2h over g, 8h, sorry, 8h, that is to say, t is calculated with square root of 8h over g. So this one is used when theta is not given, and that will give you what? Equation 18. That's not the end. That's not the end. Also, we have the relationship between v, y, or uy to say, relationship. We need to get it right at this point in time. Let's say we are given, let me redraw that thing that I drew initially. Theta, ux, uy, and u. From here, all we know is that uy squared plus ux squared is equal to u squared from Pythagoras theorem. At times they will give you u, x, or uy. They will ask to calculate the what? They will ask you to go and calculate the u itself. I have to calculate the u itself. So if that's the case, just use Pythagoras theorem, you get your answer. So u here will give you what? U equals square root of uy squared plus ux squared. From here also, we can see that tan theta, if you want to get the angle here, you are not given. You just say tan theta equals opposite uy over ux. So with this, I've done justice to everything you need in projectile. And next class, probably tomorrow, this is equation 20. Equation 20. Probably tomorrow, be expecting solutions of questions on projectile. You might be wondering that who is this person talking? It is one and only your pioneer maths and physics coach. And my name is Ogbon Tajudeen. I teach maths, physics, further maths on this channel. So you can bring your difficult part of maths, physics, further maths, SS1, SS2, SS3, so that I can help you out on those things. And if you are new on this channel, quickly click the subscription button. And at the same time, turn on the notification bell so that you can be part that will get the information at first immediately I upload it online. So, and if you want to contact me, the number you will see here being written here is my number. You can WhatsApp me, you can use Telegram, see me there anytime. I will respond to you anytime. So this number, you can call it so that you can get me on time in case you want to ask question or make clarification. This is the number you call at any time. I say again, I remain your one and only pioneer maths and physics class. Thank you for listening. See you when I see you, and bye for now.